The title of this paper is Optimization of Quantum Secret Sharing Communication Using Corresponding Bits. The goals of this paper is a true user's quantum secret sharing procedure by means of secure direct communication. The procedure is an improved version of Wang and his research group in terms of efficiency. The improvement is achieved by introducing a new concept of encoded classical bits in the decoding phase. No qubit is transferred to send the message because of using quantum network, so procedure is fully safe. For introduction, the modern quantum material begins by discovering the quantum K distribution, or QKD. The novel significant field is an innovation in quantum cryptography. The first QKD method was named BB84, which Bennett and Bossard suggested in 1984. In this method, the authors provided a technique for establishing a secretive K with unconditional security. In this, K is used. This K is used for encoding data in a classical cryptography protocol. Page and his group proposed a novel method in the quantum communication in 2002. They transmit a secret message by sending qubit directly without the initial K distribution for encryption. This new field was named Quantum Secure Direct Communication, or QSDC. Quantum secret sharing, or QSS, is defined based on quantum mechanics and classical cryptography, which is another significant branch of quantum cryptography. In QSS, the center that named Alice doesn't trust her users, and the honesty of the receivers is not known. So Alice doesn't transmit the secret message to her headset directly. She breaches the message to encrypted pieces and sends them to the receivers, such that none of them can achieve Alice's message alone. But if they collaborate each other, can read secret message. In this way, Alice can prevent the action of the dishonest user. In 2007, Wang and his research group suggested a QSS procedure by means of QSDC and teleportation. In this protocol, one bit secret message is transmitted to receivers which named Bob and Charlie, such that the message is obtained if they collaborate each other. In this paper, instead of increasing the number of used qubits, two classical bits are announced by Alice in the decoding phase. The bits are chosen such that they help the receivers to discover the 3-bit secret message, but with no leakage of information for eavesdropper. For proposing the protocol, the first step is preparing phase. That Alice arranges a series of n systematic triplet of entangled qubit in GHZ state as following. Alice separates the first qubits of each triplet and name this new sequence as sequence A. She prepares sequence B and C and keeps sequence A for herself. She sends the qubits B and C to Bob and Charlie. For testing the security of procedure, Alice chooses randomly sufficient qubits of sequence A for testing qubits. To amount the testing qubits, she arbitrarily chooses one of the Z or X bases for each testing qubits. Alice pronounces the instructions and the states of the testing qubits to receivers Bob and Charlie measured the corresponding bits in the same evaluation states. After evaluating the error rate according to the following table, if the honesty of the communication and the network is proven, the measurement results must be completely correlated. In encoding phase, by generating one auxiliary qubit as following, Alice encoded 3 bits secret message. The state of the whole system is as following. According to the following table, the operates defined operations on her qubits based on the secret message. Then she sends qubits smaller a as the controller and bigger a as the target over a CNOT gates. In the last step of the encoding phase, Alice spreads the auxiliary qubit over the hot-on-marked gate. The whole state is one of the following states when the secret message is IJK. Also, the qubits A, B, C are written in X spaces. In decoding phase, Bob and Charlie measures and announces the results in X spaces to each other. Alice measures the auxiliary qubits in Z bases and qubits A in X spaces and announces to receivers as shown in following table. They can found the secret message in one of the 4 cases. Alice announces 1 bit encoded classical bit which is working out by the measurement result of auxiliary qubit XOR the first corresponding bit. According to the following table, the first corresponding bit depends on the agent's measurement result, so it cannot achieve the corresponding bit. By this announcement, Bob and Charlie can achieve the auxiliary qubit. Alice announces another 1 bit encoded classical bit which is working out by the second corresponding bit XOR the first corresponding bit. The second corresponding bit is defined in following table. By this announcement, the receivers can obtain the message. In efficiency analysis, we must compute the eta 1 or eta 2. Eta 1 is the efficiency equation for quantum communication, and eta 2 for QSS protocols. According to the following table, performance of purpose protocol is better than previous works and the efficiency is remarkably improved. Thanks for attention.